This is example 2-1. We're going to talk about a compressible fluid. So we have a liquid that has a density that varies with depth. We're given the density change there in that little equation. And we're now asked what the pressure would be at a depth of 25 meters. So based on that, we can write, we know it's compressible, so dP dz is equal to gamma. In our derivation, we had negative gamma, but that was because we had a coordinate system that was positive upward. Now we have a coordinate system that's positive downward, so we don't need that negative sign. So gamma now is, of course, just rho times g, and we're given what our rho looks like, so we can say it's g times 11.75 times h plus 825. Now we can solve that for dP, so we can integrate. dP is then going to be g times our little equation times h plus 825. All of that times, oh, we already have the g over there, so we're left with times dz. Then we can integrate. So P is going to be the integral from 0 to h, that's the depth we want to go to, over what we have over there. 75 times h plus 825 times dz. Now the h we can pull out of our bracket, out of our integral, and then we can integrate the rest. All right, that'd be 11.75 divided by 2. And of course these are no longer h's. Let's get rid of these h's here. These are of course now z's. You write those in here. Otherwise it'd be hard to integrate. So that would be now z squared plus 825z. And that's not a round bracket but a square bracket from 0 to h. All right, so what does that give us? The zeros are going to drop out, so we can say g 11.75 divided by 2 is 5.875. We plug in it, so it'll be h squared plus 825h, and that's it. Plug in values. 981 meters per second squared times 5.875 times, now our height, our depth was going to be 25. And we'll leave the units out because in these equations they're often useless. Plus 825 times 25. And if you plug those all in and recognize that all of this back here has to be a density times a length, then we get 2.38352 times 10 to the 5 Pascal. And of course that is then the same as 238 kilopascal. So that'd be our solution. So at 25 meters, you'd have a pressure of 238 kilopascals.